Hello, I'm Austin Delapina, and I'm going to be showing how to do part one for the final project. So to get the NACA 2415 airfoil, we come over to airfoiltools.com, and I did a chord length of 1 meter, and you can change the angle of attack here, whatever you want it to be. So we'll just do a 15 angle of attack. And to get the coordinates, just download a CSV file, and an Excel sheet will pop up. Like this, and all you need are these set of coordinates here. So we're going to delete everything else. Oops. And you need to make sure the first row matches the last row. Wow. I keep hitting Control C twice. There we go. And then you need all zeros for the Z coordinate. From there, we're going to save this. Need to save it as a, so we'll do video 15 angle of attack. You just save it as a text file, tab delimited. And so these are all the ones that I already have saved. So we're going to save this here. And then I uploaded, or imported, I should say, it into SolidWorks first. So how you would do that is here you would go to Insert, you'd go to Curve, curve through XYZ points, and then when you do that, it would bring up this window right here. You go to Browse. Let's see here. Look for a text file right here. And then you hit OK. So there's the airfoil, and then you would create a box around it and go to surface and make it a plane, surface to plane. From the sketch, I just have a couple constraints. Just the leading edge of the airfoil is horizontal with the midpoint of this line, and the midpoint of this center line is vertical with the midpoint of this top line. And then that's all you have to do for that. We're going to save this as an EAS file, video 15 area angle of attack. Save it as a EAS file, and this is much easier than building it in Fluent. Like, everyone should do it this way. Save that, and then in the Fluent workbench, I was just doing the project, I just finished it, so I have one loaded in already. It would say, I forget what it would say here. It would be, I think it would import geometry or something like that instead of replace, but it's the same thing. You just go to Browse, import this into here. You're going to edit the geometry and generate it. And bang, there it is, easy. Exit out of this. I'm going to come into the mesh. Now the mesh is already set up, but I'll show the settings, or I guess the mesh settings that I have. So wait for this to load. So we have the all triangles method with, I guess I need to update it first. So let's do that. So all triangles method, here's the size down here. With our name sections, inlet, outlet, walls, and the airfoil itself. Pretty standard as the other projects go. So the mesh is created. Close out of this. From the mesh, we go into setup, double precision, and we'll just wait like 10 years for this thing to load up. I hate how long it takes for this to load. Cool. From here, we want to make sure this is laminar. Boundary conditions, inlet, the free stream velocity, we were told to set at 15 meters per second, which it is. Reference values we're going to take from the inlet. The CD and CL values are here, so you would just go to new, force, drag, and lift, and then you would be met with this page here. So this is drag, and you would select the airfoil. We have the plot that will be made, and that's it. That's all you have to do. You hit OK, and then same thing for CL. For the, and I did that after calculations. Okay, so then you just want to initialize it. This does not matter. Come over to run calculations. Calculate it. Calculations are complete. Come down to contours, same thing, you'd hit new contour. And we're doing static pressure, so you just highlight all these static pressure and velocity. Make it smooth, check the contour lines. I already have them made, so I'm just going to display them. Here's the static pressure at 15 degrees, angle of attack, and the velocity profile at 15 degrees, angle of attack. And then to get the CD and CL values, you just come over here, double click on it, hit compute, and there's your CD, and hit OK. And you come to CL, hit compute, and there's that. And that's it. That's the first part of the project.